Hi friends, welcome to another session of solving previous year's GATE question papers. This is a problem which appeared in GATE 2022. It was a numerical aptitude type problem. It carried 2 marks. In an electrostatic field, the electric displacement density vector D is given by D equals to x cube I cap plus y cube j cap plus xy squared k cap, where I, j, k are the unit vectors along x-axis, y-axis and z-axis respectively. Consider a cubic region R centered at the origin with each side of length 1 meter and vertices at plus or minus 0.5 meter, plus or minus 0.5 meter, plus or minus 0.5 meter. The electric charge enclosed within R is dash coulomb. This problem can be solved in 2 ways. The straightforward way is to calculate the closed surface integral of D dot ds. The other way is to use Divergence theorem and find the volume integral. Let me do the first way of solving this problem. In another video, I'll show you how to do it using Divergence theorem. Now we know that the charge enclosed is the closed integral of D dot ds is equal to the charge enclosed. Now here it's a cubical region. So a cube has 6 surfaces. So each surface there are 6 surfaces. Let me write down the 6 surfaces. The first surface is x is equal to plus 0.5 meter. And in this case, ds will be dy dz I cap. For x is equal to minus 0.5 meter, ds will be minus dy dz I cap. So for x, y equal to plus 0.5 meter, ds vector will be dy will not be there, dx dz will be there, and j cap. And for y equal to minus 0.5 meter, ds vector will be ds vector will be minus dx dz j. Similarly, for z equal to plus 0.5 meter, ds vector will be dx dy k cap. For z equal to minus 0.5 meter, ds vector will be minus dx dy k cap. Now let us find this surface integral for each of these surfaces and add all of them. Then you will get the charge enclosed by the cubical region. Now D is given as x cube I cap plus y cube j cap plus xy squared k. Now D, let me write D. X cube I cap plus y cube j cap plus xy squared k cap. Now let us find out d dot ds for x equal plus 5. So at x equal to plus 0.5, integral d dot ds to be only y and z are changing. Y is equal to minus 0.5 to 0.5. Z is equal to minus 0.5 to 0.5. This is equal to, since you have ds is d by dz I cap, when you take t dot ds, the j term and k term vanish because j dot I is 0 and k dot I is 0. So you'll have only double integral minus 0.5 to 0.5, 0.5 x cube dy dz. Okay. Now the integration is with respect to y and z, and the term here, the function is a function of x or y. So x as far as y and z are concerned, it's a constant and you can bring it out. So it is actually x cube into integral of dy is y and integral of dz is z, and if you put the limits, it becomes y between the limits minus 0.5 to 0.5 and z between the limits minus 0.5 to 0.5. So you get, when you put the limit 0.5 to minus 0.5, 0.5 minus minus 0.5 is 1. Similarly for z, 0.5 minus 0.5 is 1. So effectively it becomes x cubed. And if you put the value of x is equal to 0.5, you get 0.5 to whole cube, which is 0.125. Now at x is equal to minus 0.5, the ds vector is minus dy dz I cap. So the function becomes minus s cube. Okay, and again in that case, for x is equal to, by observation, at x is equal to minus 0.5 meter, the surface integral is surface integral of d dot ds is minus s cube, and if you substitute minus 0.5, you get again 0.125. Okay, now at y equal to plus 0.5, again you get y cube, and if you put y equal to 0.5, you will get by observation at x y equal to plus 0.5 meter, again integral d dot ds is equal to 0.125. The same thing applies to y equal to minus 0.5. So at y equal to minus 0.5, at y equal to minus 0.5 meter, integral d dot ds is minus y cube, which is again 0.125. Now what remains is integration with respect to for z equal to plus 0.5 and z equal to minus 0.5. When you put z equal to plus 0.5, you get integral x y squared. So let us do that at x at z equal to plus 0.5, it becomes d dot ds becomes, you take the z component alone, so it is you are integrating with respect to y and x. So xy squared dx dy. Now if you integrate x with respect to, if you integrate x, you get x squared by 2, and since x squared is same for plus 0.5 and minus 0.5. So if you integrate it with respect to x first, so let us put this, write it down. I'm integrating with respect to x, so if I get x squared by 2, I put the limits minus 0.5 to 0.5 dy. So when I put x equal to plus 0.5, I get 0.25. When I put x equal to minus 0.5 also, I get 0.25. When I subtract upper limit to and lower limit, I get 0. So it is effectively 0. The same thing applies to z is equal to minus 0.5. So the total charge enclosed Q is, so for z is equal to minus 0.5 also, integral T dot ds is 0. So charge enclosed is, for x equal to plus 0.5 it is 0.125, x equal to minus 0.5 it is 0.125, y is equal to plus 0.5 it is 0.125, y is equal to minus 0.5 it is 0.125. For z equal to 0 it is, z is equal to 0.5 it is 0, z is equal to minus 0.5 is 0. So effectively it is 0.125 plus 0.125 plus 0.125 plus 0.125, or it is 0.5 Coulomb. This is the answer to the problem. Thank you. God bless you.